Is the first member of the P2 subcluster, and we first identified tortellini through a pool of phages that we sequenced in a batch, and then identified through multiple methods, but our best evidence is our restriction digest here, compared to the known sequence that we had going back from that. The reason what classifies a subcluster is around 75% nucleotide identity versus cluster is about 50% nucleotide identity.
So once we determined that tortellini was the P2 subcluster, we were able to start analyzing its genome using specifically FAMRater. Here we have a figure of tortellini's genome on the bottom, compared with two other members of the P1 subcluster, Perky and Fiancé. Perky was the most closely related to tortellini, and Fiancé was chosen as a typical P1 subcluster. As you can see, the tortellini has a large amount of genomic discrepancy in the latter half of its genome when compared to the other two P1 cluster phages. This is what places tortellini in the P2 subcluster with this great genetic diversity. The most interesting facet of this genome is centered around here, around genes 30 to 35. Gene 33 is a bacterial integrase, which, and then I think a row of 7 genes in this area are all bacterial in origin, which were placed in this genome through the bacterial integrase. So this is a phage with a myriad of different sources from each of these genes. From this image, you can see it is a temperate phage, which gives it ample opportunities for lateral gene transfer, which could explain many of the foreign sources of its genes.
So there's a paper out there that says cluster and subcluster identifications can be classified by the sequence of tape measure, and when using FAMRater, the FAM that tortellini's tape measure gene belongs to comes from FAM 7025. The only closely related member is the Perky, has about 90% identity, versus the rest of the P cluster has about an average of 50% identity. So, based on tape measure alone, Perky would be a part of the P2 subcluster, but it's this back-end homology that really shows it wasn't. Other than that, related to the general P1 subcluster, 50% identity makes it a P cluster, but not making that 75-ish mark makes it a P2 subcluster. So we actually have a dot plot of this to show tortellini versus Fiancé, which is our general P1, and tortellini versus Perky, which is our closest related phage, which has strong homology across the whole. From there, we were more interested in what the other sources of gene information comes from that back end. And so we took all the FAMs present in this latter half, it's genes 30 to 73. We looked at what families what clusters were present in those FAMs, and then we listed them by frequency. The highest one here is the F cluster with 20 members. And then second was the N cluster, which I thought was pretty interesting because the N cluster is only 4 or 5 sequences at this point. And from there, we want to do a little more information about the F cluster.
Yeah, so the interesting thing, this FAMRater diagram displays tortellini's genome on the bottom compared with an F1 cluster phage awesome sauce, and this is the back half of the genome, which corresponds to right here. And interestingly, there's much more homology present between these two phages in completely different clusters than there are between phages in just different subclusters, which shows just the immense diversity present in the back half of the tortellini genome.
Thank you.